In this presentation we introduce the idea of dispersion. Now, the data values in a sample are not all the same necessarily. This variation between values is called dispersion. When dispersion is large, these values are widely scattered. When it is small, they are tightly clustered. There are several measures of dispersion, the most common being variance and standard deviation, which we're going to have a look at quite soon. These measures indicate to which degree the observations of a dataset are dispersed or spread out around their mean. Just to be clear, variance and standard deviation are calculated using the mean of a dataset. So there's a relationship between those two measures of dispersion and the mean. In engineering and science, high precision is associated with low dispersion. So first off, let's look at the range. Now this is a very simple measure of dispersion. The range of a dataset is a measure of the spread or dispersion of the observations. It's simply the difference between the largest and smallest observation of some characteristic, and it's very easy to calculate. However, a great deal of information is ignored when computing the range, since only the largest and smallest values are considered. The rest of the dataset is ignored. The range of values of a dataset can be greatly influenced by the presence of just one unusually large or unusually small value in the sample. We would call this an outlier. So here's a little example. The range of this dataset is calculated as follows. First off, we look for the largest value, 89. Then we look for the smallest value, 47, and calculate the difference between the two. 89 minus 47 equals 42. Now, I'm going to introduce the idea of variance. This is a more complex measure of dispersion, but it's much more useful when compared against the mean. So what we have is three data sets here, and for each of these data sets, the following statements are true. The mean is 1000 for each dataset. There are 8 elements in each dataset. The maximum and minimum is 900 and 1100 for each dataset, and therefore the range is 200. So what we're going to do is plot these little datasets together and just get an idea of how they would be different. So here's those three datasets. We have X on top, Y in the middle, and Z below. Also, what I have in the middle is this line here, which indicates the mean of the dataset. Now, so first off, let's look at X. X is pretty uniformly dispersed around the range of values. Between the minimum value 900 and the maximum value 1000, there is a very even spread of the data points around these range of values. Okay. Now let's look at Y. Y, they are clustered at the bottom of the dataset, at the lower end of the dataset I should say, and at the top end of the dataset. So in this case, when compared to Y, or compared to dataset X, Y would have very high dispersion. This is because on average, the values tend to be further away from the center of the dataset, which would be indicated by this red line here. So the average difference between a point and the mean is actually quite high when compared to X. So let's look at dataset Z, or Z. So here in this dataset we have one point around 900, this is the minimum, and another point at 1100, which is the maximum, but most of the values are actually clustered around quite closely around the mean. So by comparison to X, this dataset has very low dispersion. So on average, most of the values are quite close to the mean, so the dispersion is very low. And that is it. So to finish off, we're going to discuss this idea of sample variance and sample standard deviation a little bit before we go. So as I said before, it is a measure of the spread or dispersion of a data within a data set of sample data. It is the sum of the squared deviations from their mean divided by one less than the number of observations in the data set. So essentially it looks like this. What we do is for each value, subtract the mean, square it, sum up all these values, and divide it by n minus 1, the sample size minus 1. The standard deviation is the square root of the dataset, of the variance, and it's commonly used in preference to variance because it's denominated in the same units as the mean. For example, if dealing with time units, we would have a variance of something like 25 square minutes, where the equivalent standard deviation would be 5 minutes. Population standard deviation is denoted sigma. Sample standard deviation is simply denoted S. That's just a quick comment about